Good afternoon everyone. My name is Shabdasri Mahadev Lohar. I am from TY CSCA and my roll number is 16 and I am here to give presentation on peephole optimization. So first of all we will see what is peephole optimization. Peephole optimization is a type of code optimization which is performed on small part of the code. It is performed on a very small set of instructions in a segment of code. And when to optimize the code, optimization of code is often performed at the end of development of stage, since it reduces the readability and adds code that is used to increase the performance. Then why to optimize the code? Optimizing an algorithm is beyond the scope of the code optimization phase. So the program is optimized and it may involve reducing the size of the code. So optimization helps to reduce the space consumed and increases the speed of compilation. As bigger the code will get, that much time code will need to get compiled. So minimum lines of code will execute or get compiled faster. So code optimization is needed to increase the speed of compilation. Then manually analyzing the datasets involves a lot of time. Hence we make the use of software like Tableau for data analysis. Similarly, manually performing the code optimization is also tedious. So it is better to done using a code optimizer. Means if a human is doing code optimization, then it will need much time and that is not efficient way of doing this. So there are so many softwares for data analysis. So here in code optimization we use code optimizer for reducing the code. And optimized code often promotes reusability. After we will see types of code optimization. The optimization process can be broadly classified into two types, as machine independent optimization and second one is machine dependent optimization. Firstly we will see machine independent optimization. This code optimization phase attempts to improve the intermediate code to get a better target code as the output. Intermediate code means code which get after pre-processing. The part of intermediate code is which is transferred here does not involve any CPU registers or absolute memory locations. Then we'll see what is machine dependent optimization. Machine dependent optimization is done after the target code has been generated and when the code is transformed according to the target machine architecture. It involves CPU registers and may have absolute memory reference rather than relative reference. Machine dependent optimizers put efforts to take maximum advantage of the memory hierarchy. Then we'll see ways to optimize code. There are 4 ways to optimize the code. First is co-compile time evaluation. Some expressions involving constants can be computed at compile time, reducing runtime overhead. For example, A is 2 into 22.0 upon 7.0 into R. It is evaluated during the compilation. Then variable propagation. If a variable is assigned another variable's value, then it remains unchanged and it can be directly replaced. For example, if d is equal to x into b plus 4, then it becomes d is equal to f into b plus 4. Then third one is constant propagation. If a variable is assigned a constant and it never changes, it is replaced by its constant value. For example, we have declared a constant value and then we have taken that variable in a sum or in a equation, then that value will be replaced by the value we have already stored. So that values will never be changed. Then fourth one is constant folding. Expression with constant values are computed at compile time. For example, k is equal to 5 and x is equal to 2 into k, then it results into x is equal to 10 as we have stored k's value into 5. Then there is copy propagation. If one variable is assigned to the another and remains unchanged, then the first variable can be replaced by the second. For example, if d is equal to x into b plus 4 is optimized to a into b plus 4, means x and a value is same. Then common sub expression elimination. A repeated computation of same expressions are eliminated by storing the result. For example, if a into b and x into b are computed once instead of twice because x and a have similar values. Then dead code elimination. Code that does not affect the program's output is removed, means they don't have any role in that code, so what is point of keeping them in the code? So that code is removed from the code. For example, unused variables or redundant assignments are deleted. Then unreachable code elimination. Code that can never be executed is removed. For example, code after return is deleted as it will never run. So there is no point of code which will not run. So that is also removed in code optimization. Then there is function inlining. Instead of calling a function, its code is directly inserted where it is used, reducing function call overhead. For example, inline functions in C++. Then there is function cloning. Multiple optimized versions of functions are created to different input cases. For example, function overloading in C++. Then induction variable and strength reduction, optimizing loop variables and replacing expensive operations with simpler ones. For example, a is equal to a into 16, then it is rewritten as a less than 4. Then we'll see advantages of code optimization, as performance will be improved, as whatever code we don't need or whatever variables we don't need in code, they will be removed, so performance of code will be improved. Then reduction in code size, as I said, the code which we don't require in running or taking the output, that will be removed from the code, so code size will be reduced. Then increased portability. Code optimization can result in the code that is more portable across different platforms. Then reduced power consumption. Code optimization can lead to the code that consumes less power, making it more energy efficient, because higher the size of the code, that much power we will need to run that code. So code optimization reduces the code, so automatically power consumption will be less. Then there is improved maintainability. Smaller the code, maintenance of that code will be much easier than a bigger code. Then we'll see what are the disadvantages of code optimization. First is increased compilation time. Code optimization can significantly increase the compilation time, which can be a significant drawback when developing a large software system, because code optimization involves such a much time to remove unwanted thing from code, so compilation time will be increased. Then increased complexity, as code optimization can result in more complex code, making it harder to understand and debug, but size of the code will be reduced. Potential for introducing bugs. Code optimization can introduce bugs into the code if not done carefully, so it should be done very carefully. Then difficulty in assessing the effectiveness. It can be difficult to determine the effectiveness of the code optimization, making it hard to justify the time and resources spent on this process. And thank you. ए मंदाड काय नाही, मी अशी